Now that we've created bivariate tables in R, let's look at how to make measures of association. So again, in a previous video, we already took some SPSS data and we put it into a data frame called dataset. Let's just look at the namespace of that data frame. So if we run the names command on the data frame object, we see we have several different variables. And in this video, I'm basically going to look at a few of them. Sex, are the variable that measures whether somebody's male or female. Ab-any, which is abortion attitude in the event that a woman wants to get an abortion for any reason. And then we'll look again at health and happiness. And notice that everything is uppercase. So I'll probably do some recoding, and some of these names will change to lowercase when I do that. Okay, so going back to my script, like before, like in the last video, I'm going to attach this data set and then later detach it. That way we don't have to specify the full name of the data frame in which the variables are located. It'll automatically do that. And so the first thing I'm going to do is bring in the car library package. So I can use any functions that are part of the car library. And the one that I'm going to use specifically is recode. So I'm going to take the existing value of abortion attitude for any reason, and I'm going to recode it into a new variable, which is basically just a lowercase version. And I'm going to take the values 0, 8, and 9, and I'm going to recode them so that they're non-applicable. That is, I'm going to be coding them to missing, because I don't want to include them in the analysis. And so once I run this, because I've attached it, it'll automatically make a variable in my data set called ab-any. And so I just have to make sure I attach it before I run it. There we go. Okay, now the first thing I'm going to do is I'm going to create a bivariate table looking at the relationship between sex and abortion attitude. And notice that I'm using the new recoded version, which is lowercase, and the uppercase value of sex. So we'll first create a table. And then from that table, we can use some user-written packages to calculate lambda, showing the relationship between the two variables. And in order to do that, we're going to have to install a new package. And the package is called desk tools. So just use the install packages command to install the desk tools package. I've already done this, so I'm not going to do it. But just hit run, and it'll install it. And then once it's installed, just use the library command to bring in the desk tools library. Now we can basically use any command that's in this desk tools library. And the command that we're going to use is lambda. So lambda is going to calculate lambda, the value for our measure association for these two nominal variables. And so I'm going to run the lambda command on the table that I created up here, my table, and I'm going to have to tell it which direction to use, so it knows which version of lambda to use. Basically, this tells me where the independent variable is located, and the independent variable in this case is going to be located in the column, and so that's what we're going to do to calculate lambda. So if we run that, and then we look at our output, notice that it calculates a lambda value of 0. So that just tells us that these two variables are totally unassociated in this sample. Okay, so now that we've looked at lambda, let's take a look at gamma, and let's look at the value of gamma for two ordinal variables, health and happiness. So I'm going to do the same thing I just did. I'm going to use a table to create a new table that I'm going to call my table. And again, this will overwrite the existing value of my table, and it will have new data. And this will have the values of health and happiness. And remember that in my previous video, I recoded the values of health and happiness from the original, and I designated them as ordinal variables, in which I mapped the levels to value labels for each of these variables. So you make sure you run all of this again if you're starting from scratch. So if you're starting anew, make sure you run it again. And so now what I'm going to do is I'm just going to run my table on health and happiness. And then within the desk tools library, there's another command called Goodman-Kruskal gamma. And that's the command that we're going to use on my table. And if we run that and look at our output window, we'll notice that we have a value of gamma that's equal to 0.398. If we round it, about 0.4, so 40% of the variation in our dependent variable is going to be explained by our independent variable. And if you recall, our independent variable is going to be health, and our dependent variable, our dependent variable is going to be health, our independent variable is going to be happiness. So 40% of the value of health is explained by happiness. And it's a positive relationship, meaning that as health increases, so does happiness, and vice versa. Okay, and then to end this session, basically we're just going to detach our data set. And that means that if we were to start again at this point, we would have to type out the name of the data frame within which each of these variables is located. But we just should do this as sort of a housekeeping technique so that we don't have to, so that we don't create any errors in the future. And so basically that's how we're going to create measures of association for nominal ordinal variables in R.